All right, so we're looking at the last part of this unit. Okay, this is, we're looking at system of equations, which of course is just more than one. For the most part, I mean, yes, it's linear equations, but we're going to mix linear equations with square root functions and also quadratic. So we'll be looking at where those two types of equations will intersect or meet. Okay, so the what, why, and how. Well, the what, we will review how to determine the solutions of two linear functions, and also a linear function and a quadratic, and also a square root function. Why solving for two equations is useful when doing cost quantity problems or any type of word problem that actually is the method, the way that you would solve actually lots of word problems. How do we know if accomplished today is what? Well, if you can find the solutions to the following system of equations. So if I gave you the system of equations, which is a linear function and a square root function, right? Linear, square root. Okay, so this one, don't worry about writing. Also, the notes, you guys are just gonna, just take notes on paper, okay, with examples. So if you're asked to solve this, okay, this is something you would see in Algebra 1 or Algebra 2. You have two linear functions. Well, first thing you do is you line up the equations, okay, because if there was one of them that had a y equals, that started with y equals, then we would use the substitution method. But here we're going to use the addition method. Okay, you line them up. So I got my x's, my y's, and then my numbers. And then we want something to cancel, either the x's or the y's. It doesn't matter. Here I'm going to cancel the x's. Okay, so I need a number that both 5 and 3 can turn into. So we want the smallest number that 5 and 3 can both turn into. Okay, and it just happens to be 15. So I'm going to make one of them a 15 and one of them a negative 15. Doesn't matter which one. Okay, so I'm going to multiply this one by 5. This whole, but you got to multiply the entire equation. Even though you just want to change the x, you have to change everything. And then I'm going to multiply that one by negative 3. Now this could be negative 5 and this could be positive 3. It doesn't matter. So I'm going to distribute. Notice how I distribute to everything. Don't forget that. That's going to be a negative 21. Don't forget to distribute to the last number. Distribute. And then once I've distributed, I'm going to go ahead and add up the common terms. So negative 15 and 15, well, that's what we wanted. We wanted them to cancel. Okay? If they don't cancel, we did something wrong because we didn't make them the same number. Because we only want one variable. And this variable right now is going to be y. So we've got negative 11y and equals negative 11. Then we can go ahead and solve for y. We'll do that by dividing both sides by negative 11. So y equals 1. Okay, so where they intersect is going to be on the y value is going to be 1. Okay, and then to find the x value, choose one of these equations, doesn't matter which one, and then substitute in 1 for the y value. So looks like I'm choosing the top one here, and I take 1 and I substitute it in right there where y is. So I get 5x minus 3 equals 7. Let's bring the 3 over by adding 3 to both sides. Divide both sides by 5. And I end up with x equals 2. Okay, so where they intersect is it's a coordinate, right? It's an ordered pair, so we need to write it as such. So I'm going to write it as an ordered pair, x comma y, and it's going to be 2 comma 1. Okay, so what does that mean? Well, that means that if you were to graph them, if you were to graph each function, they would intersect at the point 2 comma 1. Well, let's see. 2 comma 1 right there. That's exactly where they cross. That's where they intersect. Okay, so what we've done is we've used the addition method here to solve. Okay, so let's look at something different. So now we have a linear function and we have this is a quadratic function. So we have a line and a parabola. So they can actually cross up to 2 times. It's possible for them not to cross at all. It's possible to cross only once, but they can also cross up to 2 times. Okay, so what I'm going to do here is I'm going to substitute, because this is like y equals x plus 3, and this is like y equals x squared plus 1. So I'm going to substitute this in right here, because if y equals this and y equals that, then that should equal this. So I'm going to substitute that in right there. So basically what I'm doing is I'm setting them equal to each other. Okay, now we have a quadratic equation, and we have to solve the quadratic equation. Okay, in order to solve this quadratic equation, I need everything on one side of the equal sign set equal to 0. So I'm going to bring everything over here. So I brought this over, I got a negative x. I brought this over, and I got 1 minus 3, which is negative 2. Okay, now to solve this, I need to factor it. Okay, so if I was to factor, I'm going to get x minus 2 times x plus 1. So let's see here. So this is how you factor. Remember, you could use x factor. And then there's a 1 here, so a times c is negative 2. B is negative 1. I need two numbers that multiply to this, that also add to this. So it's going to be negative 2 and 1. You're supposed to divide both sides, both of these numbers by a. My a value is 1. But if it's 1, you don't have to worry about it because it's not going to change it. So that's why I have x minus 2. And then this is x plus 1, because this becomes positive 1 when you reduce it. And this becomes negative 2 when you reduce it. So those are my factors, okay? So I get, when I solve, when I set each equal to 0, and I solve, I get x equals 2, and I get x equals negative 1. Okay? So I have my x values, and so since I have two x values, that means that these two functions cross each other twice. So they intersect at two different locations. One's at x equals 2, so it's going to be 2 comma something, and the other one's going to be negative 1 comma something. So either equation, whichever one you want to plug it into, will work, because remember, f of x is really just y. G of x is really just y, so I'm just going to substitute in for x. So plug in 2 right there, and I get 2 plus 3, which is 5, and then negative 1 plus 3, which is 2. So I end up with 2 comma 5 and negative 1 comma 2. Those are my two solutions. Okay, and what does that mean? As a picture, of course, as a visual. If I were to graph them, right? So we've got, this is g of x, this is the parabola, this is f of x, this is the line, and they intersect. There's 2 comma 5 right there, and then there's negative 1 comma 2 right there. All right, so it shows right here that when you do graph them, they intersect at the locations we just found. right. So last example here. So this one, we have, this is a linear function, and then this is a square root function. Okay, and anytime there's like f of x, g of x, or y equals, you're going to use the substitution method. So here I have this y equals, I could have had f of x equals whatever, because it's still a y. But I'm going to go ahead and substitute it in where the y is over here on this equation. So I'm going to take that and I'm going to substitute it. Okay, so now it's right here at 2, and then what used to be y, but y is x, square root of x plus 1, and substitute it right there. Okay, so now we need to solve for x. So we need to somehow get rid of this square root. And the only way to get rid of a square root is by squaring something. So we're going to end up having to square both sides of the equal sign. Okay, so to do this, the best way is to isolate the root. Okay, so I have this -2, and I have this square root of x plus 1 equals, and then when I brought this x over, it became a minus x. Okay, now leave the -2 here, leave it here. All right, because this is like one term. This is one term right here. I know it looks like more than one, but this is one term right now. Okay, so when we square both sides, we're not going to have to worry about distributing. Okay, and then we'll square both sides here, but when we square both sides here, it's like squaring a binomial. Okay, so I'm going to square both sides. Okay, so when I square something, remember when you square something, what you're doing is you're writing it twice, right? But like if I squared this, it would be -2 times square root of x plus 1 times -2 times square root of x plus 1. So if I was to multiply these, well, -2 times -2 is 4. And then if I multiply these together, it becomes x plus 1 squared in here, because you have x plus 1 times x plus 1. And so what happens is this actually cancels with that. So you end up with this 4 times x plus 1. Okay, so really what happens is you square this, which is a 4, and then the square cancels out that square root. But you got to put the parentheses because we're going to end up distributing. And then here, we've got -1 minus x times -1 minus x. Okay, so if you remember, we have the FOIL here. So I distribute. So -1 times -1 is 1. -1 times -x is positive x. -x times -1 is positive x. And then -x times -x is positive x squared. So if you wanted to combine like terms and rearrange it, it's actually x squared plus 2x plus 1. Okay, so we can set these equal to each other and then solve. So if we got 4x plus 4, that equals x squared plus 2x plus 1. And again, it's a quadratic like we did on the last problem. We need to bring everything over to the same side of the equal sign. So it's set equal to 0. So if I bring this over and that over, I end up with x squared. And then if I subtract 4x, that'll give me minus 2x. And then if I subtract 4, that'll give me minus 3. And then we solve it like we did before, where we factor it. So I got a minus 3, I got a minus 2. Other two numbers that multiply to negative 3, but add to negative 2. Yeah, negative 3 and 1. Okay, I'm supposed to divide by a. So I end up with x minus 3 times x plus 1. And if I solve, meaning I set equal to 0, I get x equals 3, and I get x equals negative 1. Okay, and then I would plug it into either equation, right? Either one, I can plug it into this one, or I can plug it into this one. But this one seems like it'd be easier, but this one's actually easier. Because if you plug in x right here, you get 3 plus 1, which is 4. The square root of 4 is 2, right? So one of my coordinates is 3, comma 2. And then you plug in negative 1. You end up with y equals the square root of 0. And then that equals square root of 0 is 0. So the other coordinate is negative 1, comma 0. So you got 3, comma 2. And you got negative 1, comma 0. All right. So if you're following through, this is what we did. Okay, but I showed more work. With the red pen, we distribute, set equal to 0, factor, and solve. So we got these x values. Now I take these x values and plug them in here, right? 3 plus 1 is 4, square root of 4 is 2. Negative 1 plus 1 is 0, square root of 0 is 0. And what does that mean? Well, if you were to graph them, so here's the linear function. This is the square root function. This is what square root functions look like graphed. So we've got 3, comma 2, and we've got negative 1, comma 0. And that's where they intersect. Okay, so this, of course, is the hardest one. It involves some quadratic stuff. Okay. And then you guys will have 2 problems to do for homework. All right. To stop this, where are we at?